Hey everybody, this is Greg. How are you doing? Now this week, it's very complicated, the hypothesis testing. So if you've already done your DQ, that's fine. If you haven't, just take your time on it. And if you don't think the first one's right, go in and fix it. So we've got to go slow on this. And for most people, it takes a little bit of digestion. So since this is week 5 and we're not going to have an assignment for most people, we're going to slow down and make sure we're ready for the midterm. So here's how the first DQ would work with different numbers. All right, let's say that we believe the mean of a population, like the amount of gallons of gasoline consumed by the average consumer per week is 50. So we believe that's our null hypothesis, that the mean number of gallons consumed is 50. We're going to conduct a hypothesis test to see if that's true or not, whether we can reject that null hypothesis. So the first thing we do is we take a sample from the population. So here's my sample: 45, 40, 80, 25, 90, 95, 70, 60, 70, and 80. So there's my sample of 9 of people and how much gas they've used per week in gallons. And then the next step is to compute what's called the test statistic. And this is standard across all hypothesis testing. In this case, the test statistic for a mean is the formula, t-stat, which means test statistic, is the sample mean minus the hypothesized mean divided by the quantity sample standard deviation divided by the square root of the sample size. So I need to find that number first from my sample. All right? Okay, so I've done the math ahead of time here to speed this up a little. So I'm going to put the sample mean here, x bar. I'm going to put the hypothesized mean mu here. I'm going to put, I've worked out the sample standard deviation of these numbers is about 24. I worked that out on the website that gives you standard deviation. So there's my big S, there's my sample standard deviation, and there's the square root of 9, the sample size. All right, when I do this math, so take your time and do this math, you will get a number, and that is called the test statistic. That's the test statistic. Now, when you solve these problems, you always want to have a picture drawn. So the picture helps you solidify in your mind how the problem works. Now, the next step I need to do is find the critical value from the t-table. And if I go to the t-table and I look for the two-tailed critical value, now remember our alpha, in this case, our alpha is 0.05. And I think that's the same alpha that I gave you in the problem dealing with the Auburn test scores. Okay? So, if I go to the table and I look for an alpha of 0.05, I find that my critical value with 8 degrees of freedom, remember degrees of freedom is equal to sample size minus 1. Here is my critical value. It is 2.306. So, I find the critical value from the t-table. Now, 2.306 extends this way from the mean a certain distance. All right? Now my test statistic, 1.86, extends this way from the mean a certain value. But the 1.86 does not go as far over as the 2.36. Therefore, the test stat is not, it's not true that it's greater than the critical value. And if it was greater than the critical value, we could reject the null hypothesis that the population mean is equal to 50 in favor of the alternative hypothesis that the population mean was not 50. But we cannot do that because the test stat is not larger than the critical value. Now, if the test stat were to become larger than the critical value because of the nature of the sample, make sure maybe these sample values are more extreme, then we could reject the null hypothesis at an alpha of 0.05. And so we would say there's evidence to reject the notion that the mean in the population is 50. And that's how a hypothesis test works. So you have to compute a test stat from the sample data, and then you have to know what your critical value is at any given alpha. Then you simply compare the two. And if the test stat is greater than the critical value, you can reject the null hypothesis. If it's not, you can't. Okay, so I hope that helps a little. Rerun this a few times, and by all means, I'm going to be home tonight from 8 o'clock on. Definitely call me. We can work on this together. I'm going to put some more examples up, and let's get through DQ1 first, and let's explain to each other how it works. Okay, thanks, and have a good evening.